Thank you for joining us on today's episode of the Biochar Show podcast by Biochar Today. My name is John Webster with Go Biochar, and I'm going to be your host. We are interviewing Kelpie Wilson today. Real quick, a little bit of history on Kelpie. She's a mechanical engineer, an author, an inventor. She's been doing this for a good number of years now. She's been involved with the founding in the biochar industry, working with groups such as IBI, USBI, that's the U.S. Biochar Initiative, and the International Biochar Initiative, established a program called Biochar in the Woods, as well as the Biochar on Site program. She's an inventor, an educator, an advocate, deeply committed to stewardship, ecosystem resilience, and much, much more. And also, she's a great personal friend of mine, so today's going to be a true pleasure. All right, so Kelpie, how you doing?
Hey, I'm doing great. It's a sunny day here in Southern Oregon.
Is there anything I missed on that introduction?
Sure. I've been on the planet for a while, so that's okay. People don't need to know everything about me.
Yeah. So real quick, I am going to mention that in the early days of my journey, you were a critical part because you're the one who introduced me. I think I was making a lot of noise on the internet, and so you found me, and then you introduced me to Ronald Larson and an AGU research project with biochar that was going on in Utah. That really jump-started everything for me.
It was a great discovery of mine that I found you, John, because you have added so much to our industry. And I got you hooked up with U.S. Biochar Initiative, where you worked for a while. So, yeah, you're one of my success stories.
Awesome. All right. Well, this episode's about you and about biochar and stewardship, land stewardship. So let's get started on that. So, Kelpie, thinking back, when is the first time that you discovered biochar? When is it that you first had that personal connection?
Well, can I go back a little further and talk about how I got there? Okay.
Yes.
So I got my degree in mechanical engineering back in the 1980s, and I went into the field because I was interested in renewable energy and specializing in Stirling cycle engines, which are a very interesting thermodynamic cycle for generating power. And when I got my degree, I worked for a little while as an engineer, but all the work was DoD related, Department of Defense weapons. And I didn't feel good about that because I wanted to be a hippie homesteader. So I left and I moved to the woods, and I moved off grid and lived off grid for 30 years and designed and built my own power systems, solar and small hydro. So that's how I went from engineering to basically gardening and homesteading. And during that time, I worked for an organization called the Siskiyou Regional Education Project because we have these beautiful, amazing ancient forests here in Oregon and California, Washington, that were just being mowed down, clear cut. That lumber was being exported overseas, and we're ruining our streams and our ecosystems. So I jumped into that fight and did that for about 15 years. And then, in the early 2000s, I was getting tired of just being an activist and wanted to build things more than just fight things. So I had a transitional period where I was working as a journalist and a writer for an online news service covering environment and climate issues. And that's when I heard about biochar. So just, that's how I heard about it early on because I was a journalist. So I was following these news stories, and I was especially following a lot of the peak oil writers around 2005 who were really, realizing that, hey, oil's not going to last forever. Fossil fuels are not going to last forever. And we don't really have a viable alternative that can power the industrial society we have created. So what are we going to do about that? A lot of people were writing about that at the time. One of the outlets there was called Energy Bulletin. And that's where I first read about Terra Preta. And I started reading about this like thick black soil in the Amazon that could regenerate itself. And that just sparked my thinking, light bulb went off because I was trying to grow food and I was not having a great success at it. And so when I first heard about biochar and how it was carbon that stayed in the soil for thousands of years, I thought, aha, permanent compost. Because as a homesteader gardener, you spend so much labor hauling manure every year, and it gets very tiring because your garden beds shrink because all that carbon is used up. And so you have to keep replenishing it and replenishing it. And I thought, permanent compost, I won't have to break my back hauling so much manure every year.
Yeah. And you're in the Pacific Northwest, correct?
Yes.
This is where you first started it and got going with your gardening. So yeah, that stable form of carbon is really great. I know that we have a lot of users in our community that are all starting to get a hold of it. And it's fantastic in the fact that it is best friends with compost. So you get more durable value from the times that you still do have to put the manure in there and the other amendments.
Yeah, I still use manure and compost, but it's, yeah, all works. It just is the magic ingredient that made it all come together for me.
Yeah, magic backed by science. So you did mention the Amazon and the Terra Preta. So I believe I have a photo of you in a big pit in the Amazon.
Yes, I went through the Terra Preta pit initiation. That was so much fun. So in 2010, the IBI did our international conference in Brazil, in Rio, in a big hotel and whatnot. But afterwards, there was a field trip where a bunch of us got to get on a riverboat and go up the Amazon about 50 kilometers from Manaus and visit one of the research sites that the Brazilian government has been conducting there, where they dig the pits. I'd seen pictures of them, so it was just fantastic to be there on the sites and go down in the pit and get your picture taken. Happened to be my birthday that day too, so that was special.
All right. So how did you go from being in a pit to working in the larger kind of technical side of biochar with your time at IBI?
Yeah, so when I was working as a journalist, and I'd just heard about the Terra Preta, and I wrote a couple stories about it, just scouring information, for any information that I could find. And I realized I wanted to keep writing about it, but there wasn't that much happening. So we're talking like 2006, and it's like searching and searching. Who's doing this? I want to write about it, and I realized I had to do it myself. So I was following then the Agrichar initiative, and it had been organized in the US with basically Johannes Lehmann and then the Australian folks, Stephen Joseph, and they were holding their first conference, their first international conference in Australia. And one of my writing outlets was a yoga magazine, and I was writing feature stories for them. And I asked my editor, "Will you send me to Australia to cover this? It's so interesting." And she said, "Well, I'll pay you for the article." So that covered my travel. And so I got to meet all, the initial about 100 people who attended that conference in Australia. And it was almost all soil scientists and climate people, with a smattering of Australian farmers and, other interested folks. So that was really great to meet all those people at that time. And that was the conference where the name was changed from Char to Biochar. There was a vote. Ron Larson was there. That's where I met Ron Larson. And then, a few months after I got back from that, I just thought, I want to work for the IBI. So I just contacted the folks at the IBI and I said, "Do you need any help? I'd love to work for you." And they said yes. And they gave me a contract to do communications and then project development. I ended up being the point person for managing the process with all the soil scientists and engineers to create the first standards. So the first biochar characterization standards.
I'm guessing that's part of what led to the lab analysis and picking out what needed to be measured in the physical biochar itself.
Yeah. And I was part of all those discussions. I mean, I was just facilitating it, wasn't really contributing because I'm not a soil scientist or a chemist. But so I got to be part of all the conversations where they were discussing, well, which lab method should we use for this? And what's important to measure to really characterize biochar? And how do we define biochar? And, do we define it by the temperature it's made or the process? Or do we define it by the product? So it was sort of this process versus product discussion that was very interesting.
Well, and that was also really critical to the building of the industry. Isn't that about the same time that the U.S. Biochar Initiative came online as well? So we had the International Biochar Initiative and the U.S. Biochar Initiative. Who was the board chair, or who was the leader, the executive director of IBI back then?
Back then it was Debbie Reed. So I left in 2012 to go out as a consultant on my own. USBI was started in 2010 at that Rio conference. where we went on the field trip. And Tom Miles, was always the leading light there. Tom was a mentor to me very early on. As soon as I started working for IBI, I found the stoves list that he had been managing and the bioenergy list. And, stoves was a big part for me early on. The international cook stove community had, had a big interest in biochar because of the T-lead stoves that could make it. But anyway, USBI was started at that Rio conference. We just sat down at breakfast one morning and said, all the Americans that were there, let's start a US biochar initiative. We obviously need it. So that was 2010.
Oh, fantastic. That's a great piece of history for the entire industry, right?
Yeah.
So you're making this transition. You set up the organization for the United States. And then, so what started happening then on the state side of
On the state
engagement that you
side,
had?
well, it was always just a very, very slow to get this industry rolling. And I really think that it's because of, the way to really scale this industry is it has to be connected to biomass energy. And biomass energy, the circumstances are not right for it. Maybe they will be, but as long as we have relatively cheap fossil fuels, biomass energy is not really going to be pursued at scale. And there are a lot of problems with that as well, because you can easily set up a situation. There was pushback when biochar first came on the scene from environmental advocates who looked at that and said, you want to cut down all our trees to make biochar for carbon credits? No, this is wrong. And so, and they have a point. If it's not done right, it could be a real problem. So biomass energy is one of those things that, you look at, for instance, the Drax power plant in the UK, and we have a lot of forest in the southeast that's being cut down and made into wood pellets to feed that biomass plant there. That was a converted coal plant, huge gigawatt scale plant. And that just doesn't make sense to transport that all across the ocean, to meet some carbon decarbonization objective. It really just doesn't make sense. So biomass energy done correctly is at a community scale. And an example of this is the village scale kind of thermal systems that you see in some places in Europe. And, there's another example of that in the US, Seattle Steam. So they use a couple of chip trucks full of wood every day in a biomass boiler that creates steam to heat all of downtown Seattle. That's great, but that's like 19th century technology almost, or, it's like old technology. It doesn't grab people that go, this is high tech stuff that we want to promote. So it just gets left behind in the dust. There's actually a lot of good potential for sensible biomass energy that can produce biochar. Anyway, that's why I think the industry has had problems scaling up, because just to build a big plant just to make biochar doesn't make economic sense because the markets aren't there. So, when USBI formed, we really started looking at where are the markets always, trying to figure out where are the markets. And then, doing a lot of surveys, very small group initially with no funding, basically.
Yeah.
No funding. We're all working as volunteers, as board members, and trying to put together some educational materials, because to build markets for biochar, you need to tell people what it is. And it's not that easy of a story. It's multifaceted and fascinating if you're into it, but it's the biochar elevator speech is a little challenging.
Yeah, in terms of building market, I think you once told me that people would get lump charcoal and grind it up and put it in their gardens as biochar.
Yeah, I did that initially because I didn't have any and I wanted to play with it.
So playing with biochar, is that how you, between that and the cook stoves, is that how you got started in making it yourself?
Yeah. Yeah. I really wanted to make it. I wanted to use it. So, things were a little bit definitely slow on the industrial level. So a lot of us who were enthusiastic about biochar, including Ron Larson, and Tom, we started going to the cook stove conferences. And there's a wonderful conference every year in Seattle. The group's called Ethos, Engineers in Technical Service to Humanity or something like that. So, it's still a huge problem that 2 billion people in the world are cooking over wood fires in Africa, Asia, other places. And, that's not necessarily terrible to cook over wood if you've got a good stove, but a lot of times people don't. They're just cooking over an open fire. So there's been a lot of philanthropical efforts to create improved cook stoves. And some of those cook stoves can make charcoal. So we've seen that develop and become a viable option for making biochar for small farmers. During that whole process, which is still ongoing, looking at how that's done with a top lit updraft gasifier and realizing that you could make one yourself with tin cans. Just super fun. I took that, and we have a little private school where I was allowed to do a biochar semester with kindergarten through fifth grade students. And I had them all with tin cans and nails and hammers and tin snips and, 5-year-olds cutting tin cans. And we made a bunch of them and made biochar and put it in the school garden. And so that was tons of fun.
Yeah, that's the first generation STEM training in biochar.
Yes. And the thing that's so funny is that, charging biochar has always been something that people have needed to figure out. And I realized that we had lots of free fertilizer in the form of urine. And so I had these kids, and a lot of them lived kind of off grid like I did, gave them the biochar, and we had them collect urine at home and bring in their urine charge biochar for the garden. And some of these kids, they're grown up now, and they'll see me in the store and they'll go, biochar, urine. I'm still talking about it.
That's fantastic. I had my kids do the same thing. And then we'd compost it and then
So
put it in the
here's an
garden.
experiment I wanted to do, which I haven't done yet. Children's urine has growth hormone in it, right? So what if you collected some from kids and some from their parents and did a growth test comparison?
Well, that would be really interesting. And I also know that, your early work was with Johannes Lemon, and he is really focused these days on biosludge and similar, like transitioning that nutrient source into biochar and as biochar amendments.
Yeah. The thing I always want to try to emphasize whenever I give a workshop or a talk is the highest and best use of biochar is to use it to manage other organic waste streams, because we do a terrible job with our waste. We waste our waste when we should be recycling it and reusing it, especially these, organic waste streams that people used to use to grow food before they had the option of, natural gas, using that to create ammonia fertilizers, right?
Mm-hmm.
We, we're going to run out of that someday. We're going to have to get back to using our manures and our humanures and crop waste and other forms of nutrients to recycle fertility into the land.
It does seem a bit inevitable, doesn't it? Coming up with ways to handle that on both the individual level as well as the industrial scale. It's just great to see the science and the endeavors going there. So I'm guessing that from cook stoves, you went to bigger systems, and let's talk a bit about your inventor side. How many different systems did you play with before you got into something like the Oregon kiln? And can you tell us a little history about that?
Sure. So I was playing a lot with T-LUDs, but before T-LUDs, I live in a forested environment and we have a wildfire threat here. And so we do a lot of thinning and burning in burn piles just to, reduce the fire risk in our wildland urban interface. So there's a lot of burning going on. I think it was in 2009, Forest Service did a project right next to my house. And I went back afterwards and looked in the burn piles, and there's little chunks of charcoal in there. And I'm like, this should probably be okay, biochar. I mean, I've used the biochar, the barbecue hardwood lump biochar, and it worked okay. So I started just picking those lumps out of the edges of the piles where they didn't burn completely, and started using that, and it worked just fine. One of the interesting inputs into biochar in those early years also was the Japanese experience. So the very first conference in Terra, New South Wales, Australia, was attended by a contingent of Japanese scientists. And so there were, and there were papers that we could read that they had written that were translated into English. And one little short technical note described this thing called the Moki kiln. And it was just a simple ring, kind of a cone shape, very shallow, with an open bottom. And you can see pictures of it on the internet. The Moki company was selling this. It was about the different sizes. The biggest one was a meter, I think, in diameter. And you saw people throwing bamboo into it and burning it in a flame. And then they rolled that away and there was a pile of charcoal there. I thought, that's what I need, because I had previously played with a retort as well. And that I made out of a 55-gallon drum with a recirculating pipe underneath. And then I built a brick enclosure around it, built a fire underneath, filled that 55-gallon drum full of kindling, which took a long time to cut up and lay correctly. Heated that up, took a couple hours before I got some gas and flame coming out. And I mean, it was fun. It made a lot of biochar, but it took me 5 or 6 hours to complete the process. And then I ended up with one wheelbarrow load. It's like, this, I need more. I need more. So more. So I see this little Moki kiln and I thought, I'm going to make one. So I had my friend who's a welder make me one. And at first I couldn't figure out how it worked. I just filled it up and lit it on top and it just sort of petered out. I didn't load it right. And eventually I figured out that you build a kind of more loose rick in it and let it burn down. And then you keep adding more and more. And so that was the flame cap kiln. And I did a little presentation on that at the 2013 USBI conference in Massachusetts. And everybody went, whoa, we got to do that.
Yeah.
So that kind of sparked a whole bunch of people doing different versions of the flame cap kiln, like Kontiki, the Oregon kiln, the Ring of Fire kiln, and then the big box kilns. We've had a flurry, and lots of people have made their own versions of this. Shared a lot of pictures of people making flame cap kilns out of whatever piece of metal stuff they have lying around.
Equipment, yeah, like all those.
I think my favorite one was a hood from a big old truck. Like
a hood.
Yeah, just the hood from a 1950s big truck.
The scoop shape, yeah.
Yeah, so it's kind of a scoop shape.
They flipped it upside down and put it in there, and
yeah.
I've also seen the old cast iron tubs.
Yeah, a bathtub
from your house. Yeah, the bathtubs.
Big kind of container.
Yeah. So what is it? So you're listed as a co-inventor, contributor to the Oregon kiln. What was the genesis of that?
So it really got a big boost in all of that when I started hanging out with people up in just north of me in Roseburg, Oregon. And they had the Umpqua Biochar education team. They're just a group of enthusiasts who started doing a biochar expo. Really wonderful people. And I started working with them and they wanted to apply for one of these conservation innovation grants that the USDA, NRCS has. So we applied for this grant and we got $75,000 just to do projects. That basically just kept me going for 3 years. And so what we did is we went around and we recruited about a dozen different small farmers who were interested in I think the title of the project was something like using biochar to manage manure. And so they had livestock and they had, forestry debris, which everybody around here has. So we have woody debris. We're already burning in burn piles. We have animals, whether it's a small goat dairy or a large grass-fed beef operation, or some rabbits. We had a rabbitry. We had a worm farmer. Those were his livestock. So we went through the process of making biochar and then using it in the barns and then doing composting and analyzing the compost and doing plant growth trials. So I learned a tremendous amount from doing that. And we also were working with the Umpqua Community College welding department. So they would just weld up whatever kind of kilns we wanted to make. And so that was great. And I had already made a smaller version of the Oregon kiln. I called it the Oregon kiln because if you look at charcoal production and the history of charcoal production for fuel, there's been an attempt in last few decades to clean that up because it's a dirty, smoldering, smoky process. And so they were making a lot of charcoal in Missouri, and they developed probably in the 50s or 60s something they called the Missouri kiln, and it just had an afterburner that would burn up the smoke, so it was clean. So that's the Missouri kiln. I was like, well, this is the Oregon kiln. This is how we do it in Oregon. And so it was the basic design I already had, which is a truncated, shallow pyramid. But we made bigger ones. The welding department made bigger ones and made some that had fork pockets underneath, which the farmers love those because they can move it around with their tractor.
Yeah, they're. I've used those a couple of times, and they're 350 or 400 pounds. So you need four guys to.
They're heavy steel. They're 5 feet across on top. And you can make them any size, the idea's out there. I have the plans available open source on my website. So a lot of people have made them and similar ones. Warm Heart in Thailand has made a elongated one that's like a trough, which is great because they've got long pieces of bamboo. So that's one thing that I think people don't appreciate enough when they're trying to design their own biochar production kilns or devices is you have to look at your feedstock first. Design the kiln for the feedstock. Don't think you're going to design a universal, production method that's going to work for every feedstock. It's not. So yeah, it's great that people are out there experimenting and making their own designs that fit the feedstock they have.
So site appropriate and feedstock appropriate, as well as making sure you're safe and that you're not contributing to pollution in the area. So I have to admit, when I was first getting started in this, I was confused at the difference between an Oregon kiln and a UBET kiln.
Yeah.
Initially, I didn't realize they were the same thing because when I first started, I was burning in barrels in the backyard to create it. Yeah. Well, so tell us how you went from the Oregon kiln to the Ring of Fire.
Sure. So Ring of Fire was actually something that the UBET folks invented as well. And they made their first ones with just a roofing steel. So you take some old roofing steel, you cut it to like 4 feet high, bolt it together. So a bunch of panels, bunch of like 2-foot panels to make about a 6-foot diameter ring. And then they would make another one to go around that as a heat shield. So, that was Scott McCain and Don Morrison came up with that, to give them credit. And the name too, the Ring of Fire. Ded Morgan, also another person I'll mention. And I was like amazed, that it worked as well as it did. So they're really the inventors of the Ring of Fire. But what I did is I made it more robust and came up with that. Really, the key to it is the bracket design that holds it all together. So then that happened I was struggling with the Oregon kiln. It worked really well, but it was so hard to deploy because it was heavy. And, I had a trailer with a little hoist winch to move them in and out, but man, it's just heavy.
It's a lot of
I'm not
work.
really equipped for that,
Yeah.
So the Ring of Fire started looking more interesting. And this happened then in 2020, pandemic. All my workshops were canceled. I was stuck at home. All the kids were home from school. I'm like, what am I going to do with myself? I'm like, okay, I think I could do a better job with this Ring of Fire, make it so it's really functional. And so I just sat at my drawing board and played around with designs. And then I had, a local welder make the brackets for me and cut the panels and made a prototype. And then we went around to everybody's house in the neighborhood with teenagers who were home from school. And we tried it out. And I was really pleased with how it worked. So I decided to just go ahead and invest $20,000 in making a batch of kilns and see if I could sell them. And it worked. People wanted them. People bought them. And so at this point, I've made 420 and sold all of them.
Mm-hmm.
And now I have negotiated a license agreement with a larger manufacturer, Tartar USA. So they are now manufacturing and distributing during a fire kiln. So, yeah.
So I have to add here that that was a huge, huge transition for the industry, especially for the at-home, in-field, on-farm biochar industry, because now you have a trusted manufacturer of farm implements, and they are the ones that are putting this out there. They have an established distribution system. They do it throughout North America and even have global distribution available. So this was massive. I don't think that it got enough exposure, but I do want to just reiterate what a big deal this is. And you can literally go ringofire.earth, follow it, place your order, and literally have it, depending on where you are, have it at your doorstep within 2 days to a week. That is significant. So
I'm
I
pretty happy
was really
about
pleased.
that.
I know. I was really pleased to see that. The other thing I want to point out is that I really like the way you designed the heat shield. So you can either have it up a little bit higher for the protection and the airflow difference, or flip them around and do it a little bit lower. So that configuration can help you with, inconsistencies in the soil where you're doing these burns. So it's really fantastic. And then I also know that you have folks like Napachar and some others that literally, even on your first generation kilns. So Napachar, the Biochar Coalition, based in California, they have hundreds of burns in your systems and they're super
That surprised
durable.
me. I wasn't sure it would really last that long. I thought, well, if we get 50 burns, I'll be happy. And they've got hundreds. And
Hundreds, yeah.
I mean, when you design something like that, you have to think about thermal stress. You have to think about how it's going to warp and how it can endure to keep going. And so I think the reason why it lasts so long is the steel is just strong enough that it's not going to rust through, but it's light enough that it's flexible. So if it does get warped or, dented, you can bang it back out. And then the key to it really is the bracket is a heavy steel. It stabilizes the whole thing. So, and it's proven itself. I did a redesign in 2022 because I wasn't happy with the heat shield and the way it was attaching. So it was mainly about the heat shield, but also I changed the size of the panels from 3 6-foot panels to 6 4-foot panels. It was a slightly bigger diameter, which gives you a 7.5-foot diameter ring, which is better for throwing branches in, so you don't have to cut them up as much. The old kiln was 5.5 feet in diameter.
The size works for a number of reasons. It's really practical for the infill application, but you can literally, so for folks that haven't seen this before, Kelpie, would you happen to have a photo of it? Or we'll do a link to the website so they can see
Yeah,
what it is. But you can literally put this in the back of a Subaru wagon and
yeah.
transport it. Compared to that You Bet Oregon kiln where you needed a truck or a trailer and a number of individuals with some más
And
fuerte,
a
good strength.
bunch of beefy guys to move it around
Yeah.
very far in the
Yeah.
woods.
Yeah.
My other name for it is the grandma kiln because
Because a grandma can move it.
grandma can move it. Grandma can
Yeah.
set it up by herself and do everything she needs to do.
Yeah, and that's literally true. I've been selling them as part of Go Biochar for a number of years. I helped you with some of your distribution and sales as well. And I know that there were customers that called and they were older females and they were building these up on their own and running them on their own. So yeah, it's literally grandma compatible kiln. And then you also have things like fire crews, right? The fire and thinning crews that are going up into the woods, going through the wildlands and utilizing these systems. So you've got the different scale. I guess the question is, so there's a progression there between both the utilization practices, so at home, at farm, and then into the wildlands. So forests, the WUI, so wildland urban interface for fire mitigation, to hazardous fuels reduction practices that assist with all of this. And there's even some funding that's available through the USDA NRCS program conservation practice standard code 384 that allows farmers and landowners to get a cost share, and then they can process their woody biomass waste into biochar on site. And then that way it makes it a lot more affordable, and it does lean into that stewardship story, and it's really efficient for us. So can you talk a little bit more about your experience with fire crews that are using this?
Yeah, so that's been an enduring interest, ever since I picked my first charcoal chunks out of a burn pile and, try to get some crews interested in the Oregon kiln. And we did have a few contractors who have used them on jobs, especially specifically that NRCS 384 practice, which grew out of our conservation innovation grant. I mean, I got a call from the NRCS National Forester when we were about halfway through our grant project saying, we want to create a practice around this. I was like, okay, great. I don't really know what we're doing yet, but yeah, I'll give you some information. So that practice is out there. It's a little difficult to qualify for, just to caution people, but you should definitely go for it. In my area, NRCS also has just cost share for landowners to do the thinning work. And so there are various programs, depending on where you are, that will basically mostly pay for a contractor crew to come in and cut the material and pile it. But usually the landowner is responsible for burning it. So that's kind of where I'm working a lot right now, is just educating landowners on how they can, they've gotten the money to cut the material, great, but now they've got to take care of it and burn it. So, they can use a kiln or, for the really big projects that are using the fire crews, even a kiln, there's the money that's available is so limited and there's so much work to do. And the kilns are not always that practical to use on a steep slope. So actually, my work now is actually more about burn piles, biochar burn piles. So I'm just simplifying. Sometimes the way forward is not to get more complicated, but to simplify. So I think the Ring of Fire kiln is great because it makes some better use of your material. You can make more biochar with the Ring of Fire kiln than you can in a burn pile. But if you're stuck with burn piles, it's really not a big deal to change the way you light them and manage them and make biochar. And there's so many advantages of this for land stewardship. So we have, say we've got 50 piles an acre in some of these places. And these are, 6-foot diameter piles. They're hand piles. And normally what's done is, a crew will run through with a drip torch, light them all on fire, let them burn down, come back, maybe chunk them in a little bit, the pieces fall out that don't get burned. And they'll stand around and wait till they burn all the way to ash. And then they feel like they've got complete consumption and they can leave for the day. Usually they still have to come back the next day to check. So alternative is to, first of all, there's ways to build the piles so they don't fall apart so much and that they actually will hold the heat in a little bit better to make more biochar. And then we light them on top. And what that does is when you have the flame on top, you have a lot of heat and the process actually goes faster than if you make a small, light it near the bottom and you get a lot of smoke and it smolders and just takes longer because you have less heat energy to do the job. So we light it on top. It finishes pretty quickly. We chunk it in once. And then when we got a nice heap of glowing coals, we put it out with water. So the only thing you really do differently is you have to get the water tender out there. And even in remote steep slopes, you have a good water tender with a good pump. You can get 20 gallons up the hill, which is about what you need to quench a burn pile and make biochar. And you avoid the burn pile scar, which is significant, because it destroys the soil, the organic soil layer. And it's a spot where invasive plants like thistles and things can come in. And it, takes a long time for the forest floor to recover. So you save the soil, you leave biochar on site, and then we come back with native seeds and plant the understory with native seeds, and we get great germination. So that's kind of where my focus is right now, is trying to get this idea and this method out to the crews that are doing that work right now so they can do a better job.
Those burn scars can be around for 20, 30, 40 years because they sterilize the soil underneath them, and it is a lot of scarring. I really love your approach where you're returning with those native seeds, because one of the things we have to remember is that nature is the one who did millions of years of development on this process, right? We're just replicating ancient earth wisdom. We're doing it in a new way that reduces the emissions. And the plants that are the native species in the area, they're literally fire adaptive species,
Mhm.
and often the invasives are not. I know folks that I work with, they do erosion control and weed abatement. And then when they put the biochar down, just like you, they can find that the natives kick in very quick. Then that gives them the head start because the invasives don't do as well with that high carbon. So,
And that's where you really get the kind of cascading benefits of biochar because you're helping to, revegetate native ecosystems that are now going to sequester carbon. So we're trying to create this virtuous cycle that feeds on itself. So we have the initial biochar carbon, which, we're sequestering carbon from the atmosphere. But then if we can stimulate more net primary production, then we keep accumulating more and more carbon.
right.
So
Yeah.
that's really, that's the real value of biochar.
Yeah. Well, it's agency, right? We can make it at home. You can make it for your homestead. I can make it in my backyard in something that's smaller than a charcoal barbecue.
Mm-hmm.
And then I can use it on my lawn with my trees. I can use it in my garden beds. Yeah, there's the handbook. We'll touch on that. This handbook is absolutely amazing. I encourage everybody to get a copy for themselves. Cumulative experience and technical know-how and the science that Kelpie has put together and carefully curated over a number of years in order to get this to publication through Chelsea Green. It can be found online with a number of the major retailers. I actually personally purchased 20 plus copies of this book because I give them out to clients, because one of the things I want is I want them to understand the background. Kelpie, I also give out the book Burn by Kathleen Draper and Albert Bates. So I'll often give one or both books to customers. Here you go. Understand the background, understand how this works, understand why it works, and the benefits that we're providing to ecosystems. What I really like about your book is you go into some pretty deep technical information. And then on the other side of the book, you have the very practical how-to applications in soil, and even touch on some of the really older parts where we used to have advertisements in the early newspapers for the successful farmer and gardener knows to put charcoal in their soils.
Yeah, that part was so fun for me. I loved exploring the early history of biochar. It's not just Terra Preta, it's not just indigenous techniques, which are found all over the world, not just the Amazon, of using charcoal in agriculture, but also this really interesting kind of rediscovery of charcoal in the 19th century. And you can go onto Google Books and find old agricultural journals. You search them, not with biochar, but with charcoal, you find lots of stuff. I've found like a 20-page article on all the uses of charcoal in agriculture and health. And, it's just amazing. The possibilities are overwhelming. So people got it then. They totally
Yeah.
got it.
Yeah. Nature, reproducing nature's processes. The advantage is that these days we can do it in a really clean way. I mean, I even heard that they were packing bodies when they were transporting them across the country. They'd pack the bodies in the box and then fill the box with the charcoal.
Yeah, that makes
To
sense.
Yeah, yeah. So I think what I want to do is I want to transition into, well, first off, again, thank you for that book. Wonderful gift, wonderful for you to get. I've even, some of them that I bought, I'll write some notes in it and then I put it, because where I live, we have a lot of those birdhouse shaped
Oh,
little
the little small
libraries, micro
libraries.
libraries.
Oh,
Yeah. And
nice.
I'll drop copies in those.
Yeah, and you can ask your library to get it for the town library.
Yeah. Well, I've even just dropped new copies of both the Biochar Handbook and Burn just right in the return bin. I figured they'll determine a way to handle it.
Nice.
So you're an author. You have the Biochar Handbook. You have a number of technical papers that I believe you're on a dozen or several dozen technical papers as a contributor. I want to do something that's twofold here. One is I want to talk about your authorship and your contributions there. And then I want to talk about some public misconceptions, because as we go from Oregon Kiln to Ring of Fire to Big Box and the biochar conservation burn piles, I know that a lot of people that I talk to, they picture somebody doing the Boy Scout method or doing just a big burn on their property to get rid of their trash because they don't understand the value. They're burning it from the bottom, and you see these big bellowing smoke stacks that come out. And so, when you work with the local fire marshal and you say, hey, we're going to be doing this process, they can't even find you because we're doing that top lit process. So I know that you're doing the deep dive on the science. You're doing the deep dive with literal emissions testing, extensive emissions testing on the Ring of Fire and the biochar conservation piles and practices. I tie that in with the fact that we have the emissions data. We have everything documented and working. Now we're working to dispel the idea that this is a highly polluting practice, because it simply isn't. I know you have a study coming out likely in the next year, but you also worked on the RMRS with the U.S. Forest Service and the Rocky Mountain Research Station. Can you tell us a little bit about that and maybe what your efforts are in order to educate the public on better ways to do the burn piles to reduce the emissions?
Sure. Yeah. So when the NRCS came out with that 384 practice, the state, so the national, NRCS federal can come out with practice from on high, but states have to implement it. And we were having trouble getting the states to understand it because it's so new. I asked the NRCS, could I write a technical note for you that really explains this a little bit more for your state offices? And they said, well, we don't do technical notes on forestry. We let the Forest Service do those. We use what the Forest Service does. So I contacted we have a wonderful crew, actually, unfortunately, many retired now, of Forest Service researchers and also staff who were working on biochar research and also biochar implementation projects. And so really nice for U.S. Forest Service biochar crew. And I asked Deb Dumrose, who was the lead soil scientist at Rocky Mountain Research Station working with biochar, could we do some kind of technical note? And she said, yeah, that's a great idea. And found the funding. And so brought me in, on a contract to help with it. And it was basically just a survey of all the methods that we're doing right now. So it's 100 pages long. It was just published last year. It's available for free. Anybody who's interested in biochar on site should get a copy of this because it's got all the information where we really meticulously looked at every technique and analyzed what you would need to do to implement it, analyzed how much it could do, what the efficiencies were, how it could produce, what the emissions are. So we covered everything from hand piles, biochar piles, conservation burns, machine piles, which are bigger 15-foot diameter piles. We looked at the Oregon kiln, the Ring of Fire, and the big box, and then 3 different air curtain burners, the Burn Boss, which is just, it's just a regular air curtain burner that's been around for a while, small size. The Char Boss, which is similar size but has char removal attachment, and then the Tiger Cat. So we interviewed operators who use the equipment. We interviewed manufacturers. We did like site plans. We did spec sheets for each technology with the capabilities. We did site plans showing how you would lay out the job, what you would need to get there, and then have a lot of tables that just show, what kind of feedstocks are good for each one, what kind of, how much water you need to quench. So it's a really good handbook for contractors or anyone else who's thinking about getting into this and doing a business. And I think that's one of the things we've seen in the last few years with the Biochar on Site program is that people are starting to do this as a business.
Yeah, well, and that's an important way to move it forward. I do want to touch on that emissions topic because inside that RMRS document, I think it's page 68 or 69, right around there, it has the emissions chart. And so that's fantastic information. And I know that we continue to have new studies, new emissions validation, and biochar testing that shows how efficient and effective this is. So again, we're doing things in a way that will have some smoke and some steam in particular when it starts up. But when you're running this, these systems can be really nice, really clean, and highly effective.
Can I talk about a study that I worked on that really illustrates that?
Yes, absolutely.
So, I think it was 2016. the DOE funded a project called Waste to Wisdom. It was done out of Humboldt State with Hans Supan, the principal investigator. I was looking at, what do we do with all this forest slash? How can we get some beneficial use out of this rather than just burning it up on site to get rid of it? And so they looked at things like, for fuel, and mostly mobile systems that you could do in the woods, because the reason why we don't get better beneficial use out of this material is it's very remote. It's very expensive to gather it up, load it into a truck, and take it to an industrial facility. So they're looking at things you could do on site. And there was a group called Quorum that was going to do the biochar piece. So I saw that and I called them up and I said, "Do you guys need any help?" And they were like, "Oh my God, yes. We don't really know what we're doing about biochar, but we're going to get into this, but we'd love some help." So they gave me a subcontract to work with them on doing, what we did was an LCA, a life cycle analysis. And we basically looked at two different things. We looked at a flame cap kiln, and I had some data from the Oregon kiln from our projects that I could contribute to that. And then we looked at a mobile gasifier that Humboldt State had that was able to operate in the woods, just a small gasifier. And when you do the life cycle analysis, first thing you do is you look at emissions. So this gasifier had an afterburner, and it was fairly clean in terms of emissions. So the emissions profile was better than on the Oregon kiln. Not hugely better, but better, especially with methane. But when you do life cycle analysis, you have to look at the whole carbon footprint, not just emissions. And so when we looked at the whole carbon footprint, the Oregon kiln was better than this gasifier because, for one thing, when you get that flame going, that is an afterburner, so it's fairly clean for an open fire, right? And then this gasifier, well, yes, the emissions were better than the ring of fire kiln, but by the time you add in the fact that you have to chip the material, run a chipper, that has emissions. You have to dry the material. You have two different blowers in the machine that you have to operate on. And so you have to run a generator to operate these loads. And then you have some propane that you're using to fire the afterburner. By the time you add in all the loads, the Oregon kiln is cleaner, and it had a lower carbon footprint, and it was a better option. So that really clinched it for me.
Yeah, I think real quick, let's touch on what a flame cap kiln is. So let's say you have a vessel, right? The ring of fire, the Oregon kiln. You load it with your biomass, so whatever shape is appropriate and whatever production methodology is appropriate for the site. When you light this, you build up the large pile, you light it from the top so that way the heat from that burns up any of the emissions. As it comes down, since there's no oxygen coming in from the side, the flame will sit here on top. And so that's what we mean by a flame cap kiln, because you'll see the flame all the way around. You can learn about the airflow dynamics and the way that it continues to push the flame down, because as the biomass that's inside the vessel processes, it off gases. And so all those volatiles that are coming out, they have that thermal conversion as well as the flame processing of what's coming out. And that's how we are able to lower a lot of the emissions. Again, replicating natural processes, right? This is ancient earth wisdom. We're just doing it in a cleaner, more efficient way. And we have the science behind it to show that this is a viable path forward.
Yeah, it works.
It works, and it works, and it's fun. You can cook your lunch or dinner on it. It's a great way to stand around. I mean, I personally, and Kelpie, I know you've shared this idea. I personally believe that in the evolution of humankind, we have a natural attachment to fire. Everybody likes to stand around the fire, and then we communicate and hang out and sit and watch the flame and enjoy the process. We have these systems. We do it with intent. We're doing it in order to deal with the waste material often, and then we're doing it with the intent to create and capture that carbon. So this is carbon capture, everybody. And then we put that back into the local systems, whether it's cropping systems or just, again, on your landscape, even at your home. So yeah, we get that connection, we get that sense of community. And then, when we go to the industrial processes, don't get to sit around that fire so much because there's a lot of metal and emissions control scrubbers and all that. But again, we get a real strong sense of community. So out of the papers that you've contributed to, what are kind of the top two or three that you think people should read? I will add that we will put links to these documents and resources in the show notes, especially on YouTube. So you won't miss these.
Well, one of the papers that I really was happy with was the one I did for the Nebraska Forest Service. There was a technology assessment of combined heat and biochar technologies. So these are like, small scale industrial technologies that could integrate into, community needs for heat. And the scenario we were analyzing was a worm composting operation in Nebraska that needed to heat a giant warehouse full of worms in the middle of winter where it gets down to -10, in Nebraska. So that was the use case. And this was an actual worm farm. So I got to talk to the owner about what he needs. He's bringing in a certain amount of wood chips, every week and, you know, doing a pre-compost and then putting it in with the worm bins and, so it's a real world example, right? And then I went to all these vendors who were selling pyrolysis equipment and got all the specs on them. And, you have to figure out how many BTUs of heat. That's the main thing. And then how much biochar you can make and then how much compost you could make with the biochar, et cetera. So it was a really fun problem to look at. And I think I think that was that in 2019, but it's still very relevant. A lot of the vendors I looked at are still there and, have equipment for sale. And so if anybody is able to, do one of these, get the funding to do a community kind of scale pyrolysis plant, that would be a really useful document because I don't know of any other papers that have compared across some different technologies like that. So I looked at the RT char unit, which is more of a retort. I looked at a continuous retort. I looked at the BET unit, which is more of a furnace, and some gasifiers. I think we need more of that kind of, um, technological analysis for decision makers, so they can so they don't just have to go to one vendor, or we need engineering consulting firms that can do this kind of comparative work
Yeah.
for vendors. So that was a good one. And that's on the USBI website. We also did a webinar. Tom Miles helped me with this. He did the economic component. I did the techno analysis. He did the economic analysis based on that.
What are a couple of the other papers? The RMRS, I'm guessing that document is
Yes, that's the
very
U.S.
proud of.
Forest Service General Technical Report with the Rocky Mountain Research Station. I did one, and this was also one that Deb Dumrose got me involved in is a journal called the Journal of Visualized Experiments. And this was, so I started working through the Biochar in the Woods, brought in so many great people to work with, including a young man named Vian Becker, who has a carbon accounting app. So this does digital monitoring, reporting, and verification for flame cap kilns. And so he was developing that. And so I did together a paper on how to use that app. So step by step. So if you're interested in learning how you could do carbon accounting with flame cap kilns and these simple systems, we came up with a really good process for doing that in the field, and we're doing it right now. And that's all documented in a journal article and a video showing step by step what you need to do to verify that you have made good, clean biochar and how much you've made and how much carbon is in it for carbon removal accounting.
Yeah, I know Wehan has the Char app that is just about complete, and that's just something that's on your phone so you can do the MRV. So again, those MRV practices, monitoring, reporting, and verification, that is what brings the credibility about, because that is a step that allows you to move into carbon credits with the place-based systems. We already have MRV for those larger systems like you were talking about with RD, BET, and other commercial pyrolyzers and gasifiers. Now that whole segment is moving into place-based, so including the lower tech as well as the mid tech. So we've got the flame cap kilns. We have some folks that are getting their carbon credits with the Ring of Fire. and then also the mid-tech, like working on it with Tiger Cat. In fact, most likely the previous episode with this is with Zach Fire and Wyatt Catron, 3 Degrees, and they are talking about addressing the standing dead from the citrus greening. And so again, both sides of the house are getting the MRV right and showing the validation in the LCA, the total LCA, and how we can move it forward into the carbon markets. And those carbon markets are what are going to help make these processes pencil out, where we can start moving more into that horizontal scaling, because no longer does it take millions of dollars in investments to get to where you're generating carbon credits. You can literally get into it for, anywhere from a few $1,000s to, 100,000, 200,000. So it makes it a much more viable approach into those carbon markets, as well as place-based and local utilization of the waste resources and captured carbon. So that's all very exciting. One thing I want to talk about is, because you were touching on those industrial systems and community and finding out ways to pair it into the local community needs and revenue. I have been to a couple of locations where they are looking at the biochar not as the primary product, but as maybe either the secondary or tertiary product. Because typically what they're looking at first is, how do we get rid of this biomass? How do we do it in a responsible way? So waste processing, because you can lower somebody's tipping fees by getting them to bring the biomass, or if you have your own property that's long enough, or a forest or wildland that you're managing, this gives you a viable pathway to scale processing of that waste. And then later, you're either generating electricity or doing some kind of thermal capture. And then after that, you've got the biochar. And then down the road from that, you have the carbon credits. Some of the things I've seen, back to that community benefit side, is they'll have an industrial pyrolyzer and then they do a drying floor. So all the farmers in the area bring their residues in, they process it, and while they're processing it, the heat from that goes into those drying floors, and then they do crop drying. So they're replacing natural gas with an above ground resource, and then it also generates a revenue opportunity. And so the folks that are investing in these commercial systems, they're utilizing that as a way to offset the cost of that larger upfront investment. They're servicing their own needs as well as the needs for the larger community, including commercial operations. So, and I know that a lot of folks have referenced your paper on this because they're looking for ways to make it pencil out. You were talking about the enthusiast kind of position that you had in the early days, and I think we've all been there, right? We get that spark, but now we're doing that whole transition as an industry. So from a bunch of enthusiasts into just an absolute industry, moving towards the commodity markets and a way to make the larger impact.
You can take a permaculture concept here of stacking functions. Unless you're making it in a little pile in your backyard, you need to get other benefits out of the process to pay for it. So whether it's thermal energy, electricity, waste disposal, you need something like that to make it go as a commercial industry.
Yeah, I often explain it as legs. The more legs you have on the table, the more stable it is. So when you're entering into your biochar business, the 4 to 5 legs that are there, figure out which ones you can do first and how stable it'll be. So if you don't have at least 3 pathways to revenue, it's going to be a real difficult journey for you.
That's how all commerce should be, really. We shouldn't ever try to just do one thing for the most part, because that's not how nature works. Nature's always doing more than one thing. That's efficiency.
I'm all in on that as well, with you, Kelpie. And the other thing is, it just feels good, right? You're dealing with something that's a problem, and then all of a sudden you have these different opportunities all throughout. I mean, I've used biochar for years in my chicken coop. It's a great way for it to not stink, and I have fewer flies. Super practical, right? So, and then also, I'm in Utah. I add it to my lawn, and I'm using 50% less water than my neighbors that don't have biochar in their turf. Knock-on benefits are big. If we're not pumping as much water around, that doesn't use as much either coal power or diesel fuel power in order to move all that water around. So it's not only your pocketbook that's affected, it's the upstream decarbonization that you're doing. So it's kind of a win-win-win. That kind of leads me into, I know you've been on kind of an interesting kick lately with water. Do you want to talk about that at all? Because I know that water holding capacity, water in soils is a real big deal. And that's one of the larger benefits of biochar for a lot of our environments.
Yeah, well, so the water cycle people, they kind of came into my thinking during the Pacific Palisades fire last year, which was this catastrophic fire in Los Angeles, right, on the coast there, Malibu area. Just looking at that whole problem of California wildfire and what the heck is going on, and the whole water cycle has been so disrupted. And you get these hot, dry winds. We had a huge fire here in 2020 that was from the hot, dry winds that come from the east. It's like, why are we getting more of this? It's not just climate change, atmospheric heating. It's also the disruptions to the water cycle. So I started reading stuff by people like Walter Yaney. I'm not sure how you say his name, and different writers who were talking about how when you let soils dry out, soil moisture is just key because there's the small water cycle. They're the bigger hydrological cycles, planetary wide, but also there's small hydrological cycles. So as moist water comes from the ocean onto land, if there's trees there, that's great. The trees will capture the dew and the precipitation, and then vegetation emits, particulates, terpenes, even bacteria. There are nucleation sites that encourage precipitation. So it's, you can kind of keep this precipitation rolling across the landscape, as the winds move across and the water moves across in my case, from west to east, from the ocean. It brings this water further inland. And because we've channelized all the rivers, so we don't have wetlands. I mean, Central California used to be one big swamp. So it was wet and green. And now it's just a dried up desert. And, the groundwater's sinking and it's getting saline. This has profound implications, not just for wildfire threat in neighborhoods, but also for agriculture. How much of our food is grown in California and the water table sinking? It's just, it's very short-sighted not to take a good hard look at this. And so the ability of biochar to hold moisture in soil just all of a sudden became even more important to me. And so that's just a big interest that I'm trying to figure out. I'm trying to figure out how to measure it. I did some measurements myself and some biochar piles last winter where we'd gotten really good germination of our native seeds. I thought, well, it's because of the moisture. And so I stuck a moisture meter in there, and yeah, it's wetter under where the biochar is. But then I also recently realized that a moisture meter doesn't really work on biochar. So I don't really know. We need to find better ways and that's what I really want to see now, where I'd like to see more research, is monitoring the environmental impacts of biochar, whether it's seed germination, soil moisture, soil biology, just more of this kind of monitoring, not just in crops, but in natural ecosystems, to see how biochar really can contribute to revitalizing these natural ecosystems. So measuring soil moisture is complicated.
It is complicated. I think that brings up something that I know USBI is working on, right? The US Biochar Initiative. They're moving towards a practice of showing BMPs or best management practices, crop application guidance, in a way that emphasizes the do no harm concept. So here's how biochar works, here's why it works, and here's how it has the improvements without having, the perception of potential harm to soils. Because again, Kelpie, you were talking about this stable form of carbon being able to live in the soil for up to thousands of years. Farmer doesn't want to put it in his landscape if he can't trust it, right? It's a very durable investment. We want to make sure it's not doing any harm. That's what all of this effort, especially with pioneers like you, with your ongoing work, doing these studies, we're rapidly approaching that where it's more of a complete cycle of trust and understanding. So,
Can I talk about one of my pet peeves?
yes.
So, I talked about earlier about when we created the standards, the characterization standards, scientists decided this has to be a product, not a process, is how we're going to evaluate this. And so we're just going to test the product. We're going to see, does it have PAH in it? Does it have dioxin? Does it have this, and this? And those tests are really expensive, thousands of dollars. And then if your process is not completely controlled and consistent, you have to test and test and test. And that's just like, I think a lot of people felt this is going to kill the industry. And I think it did kind of slow things down. Outside the US, there was a pretty good research effort in the UK. They came up with a more process oriented kind of approach where they said, let's verify the feedstock's clean. Let's verify the processing temperature and that the machinery is working well. And then we can be pretty well assured that we don't have to test for, the expensive toxicants because they're just not going to be there. Maybe we test it once, your machine once, and then, we have other ways of making sure that it's running correctly, and we don't have to do these really expensive tests. And that may always made more sense to me. Then, for a low tech process like the Ring of Fire kiln, it's more variable, but still we know we're using clean feedstocks. We know we're making high temperature biochar. The biochars that have caused problems have mostly been low temperature biochars, or biochars made from some contaminated feedstock, or biochars made in a pressurized process. So early on, there was a gas fire in Hawaii that people were using the char. It was killing plants because it was operated at several times atmospheric pressure, and so all the volatiles condensed back into the char, and it was toxic, at least in the short term. So I mentioned that I have used barbecue charcoal before, which is made at a lower temperature, and that kind of charcoal can be perfectly fine. And this is my other pet peeve, is that people think you're just going to add biochar to soil. You should never do that. You should always compost it first. Compost it and then apply it as you would compost. That's really the only sensible way to use biochar. Other than, I think in China they're making a pelletized charcoal biochar with chemical fertilizer product. So you have like a slow release fertilizer. That makes sense, to actually make a product like that. But otherwise, compost it, because the composting, if you do have volatile material in there that usually is not, you know, persistent organic pollutants, you don't want those. You may have some tar and oil that can inhibit plant growth initially, but that all gets eaten up by the microbes in the compost. So it's not a problem. So if you just compost it first, you don't have those trust issues. Anyway, that's kind of my explication of my pet peeve.
Yeah, I personally have a pet peeve around the YouTube videos that you see where somebody has a bag of charcoal, no classification on it, no labs on it. I've worked with groups that have similar material, and when you do the labs, there's risks behind that. So I will never suggest people use a bag of charcoal. Biochar needs to be made with intent. You need to understand how it's made, the temperatures, everything you just talked about, and also suitability for purpose. That's one of my pet peeves. I do want to add on the commercial side that people like Josiah Hunt have done these multi-year, very scientific analysis on the soils and on the materials that are going in. And he has found that as long as there's a nutritional component added at the same time as the biochar, that it performs pretty well as long as they're near each other. So if you are disking in your biochar, you've got some kind of element, mineral base, organic base, that you can have high success rates and a very safe and predictable program. In terms of that at-home process, I personally always do composting with mine, or I do some kind of a mix with multiple different inputs, and then find that it works fantastic, frankly, with things like trees and even in my gardens. But composting always is kind of that optimal chef's kiss kind of thing.
Ages the biochar appropriately. So if you put plain biochar in a cropping system, if you put a little bit in and your soil's healthy, it's not a problem. But, some of the early field trials, they looked at the Terra Preta, and it was about 20 tons per hectare of charcoal that was in the Terra Preta.
Mm.
So like, oh, let's add 20 tons per hectare to this field and do a field trial. And, we'll do everything else the same to our control. Well, the control would do better because the raw biochar they just threw in there is going to hold on to some of those nutrients in the first year. And so some of the conclusions were, oh, well, this stuff's no good. Then they would come back the next year and they'd find now the biochar field's doing better. So
Hmm.
that brought home the need to do multi-year field trials.
Yeah,
Because it
yeah,
just typically
absolutely.
needs to go through that aging process where it gets charged up with nutrients and biology, and the surfaces get oxidized. And if you put it through a compost, then that's all taken care of in the compost.
Yeah, that's a really good point. Actually, that leads into your practical biochar course, where
Yeah.
you cover a lot of these in your class. So I do know that it's an online course that you can take at your own. What is it? Self-paced.
Mhm.
So how long did it take you to build this class?
Well, so the biochar handbook was published in summer of 24. So last summer, right after it came out, I got a call from Javan Bernankovich, who runs the Regenerative Living Online. He's a permaculture teacher, has a lot of really good courses. And he said, do you want to do a course? I'm like, oh gosh, well, I can't really say no. And it turned out being a ton of work. It was like having to write the book all over again. So basically, the book is a textbook for the course, and I probably cover everything in 9 sessions. And we offered it live last winter, and then it was all recorded. And Javan's done a great job of kind of chunking it up into little bits in the video. So if you take the self-paced, you can just pick, I want to watch this piece, 10-minute segment on this particular topic, or I want to sit down and watch this whole, hour-long lecture all at once on this topic. And then there's a lot of extra materials, written materials, publications, and, each class had about an hour of questions afterwards. So you can, you know, see what other questions, they had. Yeah, I'm getting tired just thinking
Yeah,
about it. It was
yeah,
so much
yeah, yeah.
work, but it was a great to have that opportunity to kind of do that download, and it's all out there now for anybody who wants it. It's a couple $100, so it's not free, but it's a good deal.
It's affordable. And does this applies to home gardeners, homesteaders, small farms? Is that kind
But
of the
anybody,
audience?
because I do cover a lot of the how to read a biochar test panel results, the chemistry. I have a whole lecture on the chemistry, cover industrial production, and applications by compost, how to do a pot trial. So I think anybody who's serious about getting into the industry, whatever your role is, whether it's building pyrolysis plants, finance, marketing, you could benefit from this. It's not just for home gardeners.
Yeah, that's fantastic. Thanks for sharing that. I guess what we should probably do is now look at the evolution of a program that you founded called Biochar in the Woods that is now Biochar on Site. Do you want to talk about that and what was kind of the genesis?
Sure. Well, I mean, I've already talked about the genesis, my experience with burn piles and working with grayback forestry let me do a lot of experiments within their projects that they
Hmm.
were doing on fuels reduction, and so we're just working with the forestry contractors and seeing that they could have ability to do something a little different. So I wrote a paper in 2015 just outlining all the ways you could do that. And then after the Ring of Fire kiln was a thing, I realized I wanted to do more workshops to teach people how to use it. And so started the Biochar in the Woods program as just a part of USBI to kind of collect the material in one place at our learning center and to amp up that educational effort. And then you came on in 2022. We decided to do a symposium that was sponsored by USBI. And we had did a like almost a day long of presentations, webinar presentations, and then we did 2 field days in California. So, and we had great attendance. I mean, I don't know how many people came to the online, probably 80 people or something. And then we had 40, 50 people in 3 days. We were up in Paradise, California, which is really interesting because, of course, that's one of the communities that was devastated by wildfire. And so, yeah, there's been a lot of interest. And then we started a listserv, and we started doing monthly meetings. And that was great because that's where we, really sort of built the network, brought in lots of people who are interested in this idea and sharing knowledge. We all learned a lot. And then last year, we realized that USBI was changing focus and they wanted to really just zero in on industry and kind of let the Biochar in the Woods program go. And so you and I and Karina Stark decided we're going to create Biochar on site. And so it's a continuation of the monthly meeting, but thanks to your good work, John, we've really transitioned to more of a webinar format. So, and it was a good timing because we went from really just an informal network of people trying things out, learning from each other. And then, quite a number of people have turned it into a business. So it's really time for people to share how they're really doing it seriously as a business. So we just keep going. And we now have a nice website and some educational materials and so forth.
Yeah. So that symposium you talked about in 2022, the day one online activities can be found on the USBI YouTube channel. If anybody wants to take the 3-year Wayback Machine journey to their channel, you can see those. I do want to point out that one of the reasons we changed the program name is because we want to be something, the Biochar on Site program wants to be something that's more applicable to a global audience. It's Biochar in the Woods, real romantic idea, right? Everybody lives in a forest, but not everybody lives in forest land. And we didn't want to give the idea that these practices are only applicable to woodlands. They're appropriate for farm scale practices, WUI, so wild urban interface around resort towns and those types of communities that Kelpie lives in, and wildlands, even on grasslands, places like that. You can utilize these processes to capture the carbon and provide those ecosystem benefits. So hence the name Biochar on Site. We do have a website at biochar.org. It'll be linked in the comments. That's our logo, and we're hoping to get more merch. We do have a website. I will add a little bit of a plea because we are effectively a civic group. We're working on becoming a nonprofit, but we could use financial support to, if somebody wants to pay for an updated website for us, things like that, if you want to volunteer your time. But the biggest way that people can participate is in those monthly webinars that Kelpie mentioned. It's the first Wednesday of every month at 12 noon Pacific time. And they last for about an hour and a half. Since the first of the year, in 2025, we've been doing a technical presentation. So we do a little update first on what's going on in the state of the industry on this side. And then we do the technical presentation followed by Q&A. We have had some extremely engaging webinars. It used to be that these monthly meetings would have anywhere from 10 to 20 people in them. We're now seeing folks upwards nearing 100 participants in these. We do have everything recorded. Again, if you want to volunteer to help or if you want to finance some of this, we are looking for a sponsor that can pay for the video editing so that we can get all of these programs past and present published to YouTube so we can get that information out there. Another thing that we're working on that Kelpie has had her hands deep into are the fact sheets. Last week or the week before, the biochar burn pile fact sheet was added to the program. When you go to our website, there's a couple of ways to get there, but you can go to the resources and then follow the link for fact sheets, and you can find a copy of it there. And it's a basic primer on the process of how to do these biochar conservation piles. Again, we're working on new ways. We have these established practices like the burn piles. We're working on new ways to improve them to increase net benefit and further reduce pollutants. So Kelpie did a great job. She contributed that fact sheet entirely to the program. And then we have the flame cap kiln fact sheet. It is also a primer. It explains the basic of what is a flame cap kiln, What does the process do? What are the benefits? Kind of how it operates. We do touch on things like emissions and safety protocols. We're looking to build upon that and do a 9 or a 10-page technical document on that. And we have a number of other fact sheets that we're going to work on. Kelpie was proposing just earlier this week a couple of that we will work on. That'll include things like safety programs, how to deal with insurance and permitting. We're working on taking it those next steps to bring it more to, you can always be that enthusiast and do it because you're dealing with something on property. But if you want to move it into a business that can pencil out, we're building those fact sheets that can help support you, as well as this program that can help support you through our monthly webinars. So that way we can focus on that horizontal scaling. The more folks that we can get to adopt this, the better off we are. We're even working on something called a train the trainer program. And so we're working with, who are the folks that we're working on that, Kelpie?
Everybody.
Everybody. Yeah. The conservation managers. We work with fire professionals, forestry groups. We talked about MRV earlier. Now, if we also have a program such as the train the trainer, where you can get certified in it, you can show that you have awareness. It'll be easier for you to secure the insurance for your commercial operations. It'll instill trust with your clients. And so by and large, this is a great way to make progress. And again, we're doing this largely on a voluntary basis, but I'm really proud, Kelpie, the work you and Karina and I are doing, because we are punching very heavy. We are punching above our weight for the amount of support we get, at least the financial support, which isn't much. We are really making a difference.
Can I just say also, there's always been a little bit of pushback from the industry against what we're doing, like as if they think we might be competition. We're really not. And you've put it well, John. You call it the last mile biochar. I'm sorry, but you're never going to get your hands on this stuff because it's never going to make it to your plant. And what we're doing really is we're advertising the educational value of this hands-on approach for people is huge. So that when somebody, maybe their kid learned about biochar making a stove in a class, and they happen to be the procurement officer for, a municipal park department. And they're like, oh, I know about biochar. Here's some biochar I could buy to improve our turf. Yes, let's do it. So the educational component of this hands-on, more grassrootsy, last mile biochar, it just complements the bigger industry. It's not a competition. Most people get that. But for those who are kind of new and might be thinking that way, don't.
So because I do consultancy just like you do, and I work with folks that are looking at building these multi-million-dollar projects. They also want to protect their feedstock. So by employing these last mile, they can get to just outside where their harvest or salvage operations are going. And by being able to reduce the biomass out there just beyond where it's commercially viable to transport it back, they're reducing the risk and assuring the safety of their feedstock supply, because that can often be one of the key hindrances of getting into a commercial plant. I've also been talking to producers that are looking to launch their programs, and they are looking to things like these mid-tech processes. So that way, when they do get their land lease, they can move in with either the air curtain carbonizers or some other type of mid-tech system in order to start producing at their location. It secures their location, allows them to start building their brand. So even though there are, like you said, there are some conceptions about this not being efficient and effective, but it really is. The MRV is showing it, the extensive emissions testing, the science, all is leading to benefit. All right, Kelpie, with that, I think we've spent enough time in our conversation. Of course, you and I have had many more hours of conversations like this over the years, and sometimes we get to gabbing just a little too much. I want to thank you so much for your participation today. It's been a true pleasure. I always enjoy your company, and I know that the audience is going to find this absolutely fantastic and fascinating. Can you take just a moment, and if you have any closing ideas, or if you just want to notify us like what's the best way to get hold of you? Are you on LinkedIn or other social media? What are your addresses?
Yeah, so I do post on Instagram. I am on LinkedIn. The best way to keep up with me, contemporaneously is my Substack. So I have a Substack called the Biochar Prepper, and I'm just reporting on what I'm doing. I'm trying to post every week. Sometimes I miss a week, but check it out there. I'm sharing pictures and stories about ongoing activities, and I have a website, Wilson Biochar. To order the Ring of Fire kiln, go to ringoffire.earth. I appreciate if you order the kiln through there rather than direct to the Tartar website, because if you order through that website, I get a little extra commission. So please do that. And, I'm always available to answer questions. If you want to send me a message on LinkedIn, I try to answer questions. And I guess to wrap it up, I'll say Biochar's been a hoot. I've really enjoyed it. It's benefited me. It's helped me grow good food for me and my family. And I kind of came for the technology, but I stayed for the people, because the
Yeah.
people involved in biochar are the best. And that includes you, John. So
Thank you, Kelpie. Yeah, the sense of community is amazing. So, okay, so real quick, everybody, everything that Kelpie just mentioned will be in the show notes below. So you can find us on all major podcast platforms as well as YouTube. My name is John Webster with Go Biochar. We do both biochar sourcing as well as consulting. Kelpie Wilson with Wilson Biochar. You can find us both online. I want to thank Timothy and the group at Biochar Today for sponsoring this program. Please be sure to check out our past episodes. There's some really fantastic ones between municipal biochar, biochar for trees, and much more. So again, Kelpie, thank you so much. It was great to see you. It was great to spend the time, and I appreciate it.